Welcome to Dormant Knowledge. I'm your host, Deb, and this is the podcast where you'll learn something fascinating while gently drifting off to sleep. Our goal is simple: to share interesting stories and ideas in a way that's engaging enough to capture your attention, but delivered at a pace that helps your mind relax and unwind. Whether you make it to the end or drift away somewhere in the middle, you'll hopefully absorb some knowledge along the way. Tonight, we're exploring the fascinating story of Pluto, that distant, icy world that has sparked more controversy than you might expect for something so far away. From its discovery to its demotion and everything we've learned in between, we'll take a journey to the edge of our solar system. So settle in, get comfortable, and let's begin our exploration of this distant world. So, Pluto, that tiny frozen world at the edge of our solar system that used to be a planet and then, wasn't anymore. Yeah, that Pluto. It's actually kind of amazing how much emotional attachment people have to this distant ball of ice that none of us will ever visit. I mean, when astronomers decided to reclassify it as a dwarf planet in 2006, people were genuinely upset. There were protests at some universities. Elementary school teachers had to update their curriculum. It was a whole thing. But before we get into all that controversy, let's start at the beginning. The story of how Pluto was discovered is pretty amazing, and it begins with, it begins with a mistake. In the late 19th century, astronomers noticed some irregularities in the orbits of Uranus and Neptune. These giant planets weren't quite where they were supposed to be based on calculations. And one explanation was that there might be another massive planet out there, tugging on them gravitationally. This hypothetical planet was sometimes called Planet X. Percival Lowell, who was also famous for claiming to see canals on Mars through his telescope, which turned out not to exist, became particularly obsessed with finding this ninth planet. In 1905, he started a systematic search for Planet X from his observatory in Flagstaff, Arizona. He continued this search until his death in 1916, but never found his mystery planet. Oh, and it's worth mentioning that the whole premise of the search was flawed. Those supposed irregularities in Neptune's orbit, they weren't real. They were based on slightly incorrect calculations of Neptune's mass. So astronomers were basically searching for something to explain an effect that didn't actually exist. But that's often how science works. We stumble onto correct answers, sometimes even when we're asking the wrong questions. Anyway, the search for Planet X resumed at Lowell Observatory in 1929 when they hired a young amateur astronomer named Clyde Tombaugh. And Tombaugh's job was, it was incredibly tedious. He had to take photographs of the same sections of the night sky several days apart and then compare them using something called a blink comparator, looking for any object that moved against the background of fixed stars. Picture this: Tombaugh would sit there for hours upon hours, looking at photographic plates with thousands of stars on them, trying to spot if any tiny dot had shifted position between two photos. It was like one of those spot the difference puzzles, but with thousands of possible differences, most of which were just artifacts or errors in the photographic process. After about a year of this painstaking work, on February 18, 1930, Tombaugh finally noticed a small moving object in the photographs he had taken in January. Additional observations confirmed that this was indeed they assumed it was a planet at the time. Lowell Observatory announced the discovery on March 13, 1930, which happened to be Percival Lowell's birthday. as well as, coincidentally, the anniversary of William Herschel's discovery of Uranus. Now, the name Pluto wasn't immediate. There was actually a bit of debate about what to call this new world. The right to suggest a name traditionally fell to the discoverer, but lots of people had opinions. Eventually, an 11-year-old schoolgirl from Oxford, England, named Venetia Burney, suggested the name Pluto after the Roman god of the underworld. This seemed fitting for a cold, dark world so far from the sun. The name was officially adopted on May 1st, 1930. And I think there's something kind of charming about that this major astronomical discovery was named by a child. Maybe that's part of why people feel so protective of Pluto. There's something a bit more human about its discovery story compared to some of the other planets. I don't have a chair. Let's talk about how Pluto fits into the naming conventions of our solar system, because it's kind of interesting. Most of the planets are named after Roman gods. Mercury is the messenger god. Venus is the goddess of love. Mars is the god of war. Jupiter is the king of the gods. Saturn is the god of agriculture. Uranus is, well, technically a Greek deity, the personification of the sky. But the Romans adopted him too. And Neptune is the god of the sea. So Pluto, the god of the underworld, fits the Roman mythology theme perfectly. And there's another neat thing about the name. The first two letters, P and L, are also the initials of Percival Lowell, which some people saw as a nice tribute to the man who started the search. Interestingly, the planet's name then influenced the naming of a newly discovered element. In 1941, scientists discovered element 94 and named it plutonium, after the planet Pluto, following the pattern of uranium being named after Uranus and neptunium after Neptune. So there's this whole interconnected naming system that spans astronomy and chemistry. Anyway, back to Pluto itself. When it was first discovered, astronomers estimated that it was roughly the size of Earth, maybe even larger. This seemed to confirm the theory that it was massive enough to affect Neptune's orbit. But as observational techniques improved, the estimated size of Pluto kept shrinking and shrinking. By the 1970s, after the discovery of Pluto's largest moon, Charon, in 1978, astronomers determined that Pluto was actually much smaller than originally thought, only about 1/5 the mass of our moon. That's way too small to have any noticeable gravitational effect on Neptune. So, why was Pluto ever considered a planet in the first place if it was so small? Well, part of it was the limited technology of the time. But there was also this inertia in scientific thinking. Once Pluto had been classified as a planet, it just stayed that way for decades, even as evidence mounted that it was quite different from the other 8 planets. Oh, and speaking of the other planets, many of us learned mnemonics to remember their order from the sun. The classic one was, "My very educated mother just served us 9 pizzas," where pizzas represented Pluto. After Pluto's demotion, people had to come up with new mnemonics. Some popular ones are, "My very educated mother just served us nachos," or "My very educated mother just served us nothing." There's a bit of sadness in that last one, isn't there? Like we're mourning the loss of our 9th planet. Let's talk about Pluto's orbit, because it's really quite strange compared to the other planets. The 8 major planets orbit the sun in nearly circular paths that all lie roughly in the same plane, called the ecliptic. But Pluto does its own thing. First, its orbit is highly elliptical, more stretched out than any of the other major planets. So elliptical, in fact, that for about 20 years of its 248-year orbit, Pluto is actually closer to the Sun than Neptune is. The last time this happened was from 1979 to 1999. And Pluto's orbit is tilted at a significant angle to the ecliptic, about 17 degrees. For comparison, the most tilted of the 8 major planets is Mercury at about 7 degrees. This means that Pluto spends most of its time either above or below the plane where the other planets orbit. These orbital peculiarities were another clue that Pluto might be something different from the other planets. It seems less like a ninth planet and more like something else entirely. Oh, sorry about that. Where was I? Right, Pluto's unusual characteristics. Another thing that sets Pluto apart is its composition. The inner planets, Mercury, Venus, Earth, and Mars, are rocky worlds. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas or ice giants with no solid surface to stand on. Pluto, by contrast, is what astronomers call an ice dwarf. It's made mostly of frozen nitrogen, methane, and carbon monoxide, with a rocky core. This composition is much more similar to some other objects in the outer solar system than it is to any of the 8 major planets. So we've got this small, icy body with a weird orbit that doesn't really fit the pattern of either the inner or outer planets. And by the 1990s, astronomers were discovering more and more objects beyond Neptune that seemed similar to Pluto. This region became known as the Kuiper Belt, named after astronomer Gerard Kuiper, who had theorized its existence. The Kuiper Belt is sort of like a second asteroid belt, but much farther out and composed mostly of icy bodies rather than rocky ones. It extends from about 30 to 50 astronomical units from the Sun. An astronomical unit, or AU, is the average distance from Earth to the Sun, about 93 million miles. So we're talking about a region starting at Neptune's orbit and extending out about 20 AU beyond it. As more objects were discovered in the Kuiper Belt, astronomers began to realize that Pluto was likely just one of many similar objects in this region. Some were quite large. In 2005, astronomers discovered an object called Eris, which was thought at the time to be even larger than Pluto, although later measurements showed it to be slightly smaller. Eris is named after the Greek goddess of discord and strife, which turned out to be appropriate given the controversy that followed. The discovery of Eris forced astronomers to confront a question they'd been avoiding. What exactly is a planet? If Pluto is a planet, then shouldn't Eris be considered one too? And what about other large Kuiper Belt objects? Should they all be planets? We could potentially end up with dozens of planets in our solar system. So in 2006, the International Astronomical Union, or IAU, set out to formally define what a planet is. They came up with 3 criteria. First, it must orbit the Sun. Second, it must have enough mass to pull itself into a roughly spherical shape. The technical term for this is hydrostatic equilibrium. And third, this is the one that did Pluto in, it must have cleared the neighborhood around its orbit. This means it must be gravitationally dominant, with no other bodies of comparable size in its orbital vicinity, except for its own satellites. Pluto satisfies the first 2 criteria, but fails the third. It shares its orbital neighborhood with numerous other Kuiper Belt objects, so under this new definition, Pluto was reclassified as a dwarf planet, a new category for objects that meet the first 2 criteria, but not the third. The IAU vote wasn't without controversy. Only about 424 astronomers were present for the vote out of thousands of professional astronomers worldwide. Some argued that the definition was arbitrary and not particularly scientific. Alan Stern, the principal investigator of the New Horizons mission to Pluto, which we'll talk about in a bit, was particularly critical. He pointed out that even Earth hasn't fully cleared its neighborhood. We still have near-Earth asteroids crossing our orbit, and he argued that the clearing the neighborhood criterion effectively classifies planets by their location rather than by their intrinsic properties, which doesn't make much sense from a scientific perspective. There's also been a lot of debate about whether the clearing criterion is too vague. What exactly counts as having cleared the neighborhood? How thoroughly cleared must it be? There's no precise quantitative threshold in the IAU definition. Despite these objections, the IAU definition has stuck, at least officially. Pluto, along with Eris, Ceres, the largest object in the asteroid belt, Haumea, and the Makemake are currently classified as dwarf planets. But the debate continues, and it's possible that the definition could be revised in the future. The public reaction to Pluto's demotion was surprisingly emotional. People held protests with signs saying Pluto is still a planet to me and size doesn't matter. Some state legislatures, including California and New Mexico, passed resolutions declaring that Pluto would always be considered a planet within their borders. New Mexico's resolution is particularly understandable since Clyde Tombaugh, Pluto's discoverer, lived much of his life there. I think what's interesting about this whole controversy is how attached people came to the idea of Pluto as a planet. Maybe it's because many of us grew up learning about the 9 planets in school. Or maybe it's because Pluto, being the smallest and most distant, was kind of an underdog that people rooted for. Or perhaps it's just resistance to changes. People didn't like having to unlearn something they thought was settled fact. Whatever the reason, the Save Pluto movement shows how scientific classifications can become culturally significant beyond their technical meaning. A planet isn't just a certain kind of astronomical object. It's something that has meaning in our cultural imagination. Let's talk about Pluto's moons, because they're pretty fascinating too. Pluto has 5 known moons. The largest by far is Charon, discovered in 1978. Charon is so large relative to Pluto that the two of them form what's called a binary system. Instead of Charon orbiting around Pluto, they both orb around a point between them called the barycenter. It's as if they're doing a cosmic dance around each other. To give you some perspective, Charon is about half the size of Pluto. Our moon, by comparison, is about a quarter the size of Earth. So Charon is proportionally bigger than our moon, which is unusual in our solar system. The other 4 moons of Pluto, Nix, Hydra, Kerberos, and Styx, are much smaller and were discovered much more recently. Nix and Hydra were found in 2005, Kerberos in 2011, and Styx in 2012. All 4 were discovered using the Hubble Space Telescope. These moons are all named after figures associated with the underworld in Greek mythology, keeping with the Pluto theme. Nix is named after the Greek goddess of night and darkness. Hydra is the 9-headed serpent that guarded the underworld. Kerberos, sometimes spelled Cerberus, is the three-headed dog that guarded the gates of the underworld, and Styx is the river that souls had to cross to enter the realm of the dead. For decades, our knowledge of Pluto was quite limited. From Earth, even with our most powerful telescopes, Pluto appears as little more than a dot of light. We could determine its orbit, estimate its size and mass, and make some educated guesses about its composition, but the details of its surface and atmosphere remained mysterious. That all changed with the New Horizons mission. New Horizons is a NASA spacecraft that was launched in January 2006. Ironically, the same year Pluto was demoted from planet status. Its primary mission was to perform a flyby study of Pluto and its moons. The mission was led by Alan Stern, who, as I mentioned earlier, has been one of the most vocal critics of Pluto's reclassification. The spacecraft took more than 9 years to reach Pluto, traveling over 3 billion miles. It finally made its closest approach to Pluto on July 14, 2015. The data and images sent back by New Horizons revolutionized our understanding of Pluto. Instead of a static, dead world, we found a surprisingly complex and geologically active place. One of the most striking features discovered was a heart-shaped region on Pluto's surface, now known as Tombaugh Regio, named after Clyde Tombaugh. The left side of the heart is a vast plain of nitrogen ice called Sputnik Planitia. This region shows evidence of glacial flows and convection cells, suggesting that the ice is slowly churning and moving like glaciers on Earth. New Horizons also revealed mountains on Pluto, likely made of water ice, that rise as high as 11,000 feet. There are vast fields of methane ice dunes. There are what appear to be cryovolcanoes, essentially ice volcanoes that erupt with a slushy mix of ice, ammonia, or methane instead of molten rock. Perhaps most surprisingly, Pluto has a thin atmosphere composed mainly of nitrogen, with traces of methane and carbon monoxide. This atmosphere expands when Pluto is closer to the Sun and freezes out onto the surface when Pluto is farther away. All of this geological and atmospheric activity was unexpected for such a small, cold world so far from the Sun. It suggests that our understanding of what drives geological processes on planetary bodies might need some revision. The New Horizons mission didn't just study Pluto, it also gave us our first good look at Charon, and Charon turned out to be fascinating in its own right. It has a dark red polar region nicknamed Mordor Macula, after the Dark Land and the Lord of the Rings. This coloration is thought to be composed of tholins, complex organic compounds that form when simple compounds like methane and nitrogen are exposed to ultraviolet radiation. Charon also has enormous chasms, one of which is deeper and longer than the Grand Canyon on Earth. This suggests that Charon, like Pluto, has experienced significant geological activity in its past. After its Pluto flyby, New Horizons continued into the Kuiper Belt, where on New Year's Day 2019 it flew by a smaller Kuiper Belt object called Arakoth, previously known as Ultima Thule. This was the most distant object ever explored by a spacecraft from Earth. Arakoth turned out to be a contact binary, two distinct lobes connected by a narrow neck, giving it a snowman-like appearance. The New Horizons mission is still ongoing. The spacecraft continues to study Kuiper Belt objects from a distance while making its way out of our solar system. it has enough power to operate until at least the mid-2030s. So we may learn even more about the outer reaches of our solar system in the years to come. I want to talk a bit more about the Kuiper Belt because understanding this region really helps us put Pluto in context. The Kuiper Belt is vast. It contains thousands of known objects and probably millions more that are too small or distant to be detected with current technology. These objects are often referred to as Kuiper Belt objects, or KBOs, or sometimes as trans-Neptunian objects, or TNOs. They're believed to be relatively pristine remnants from the early solar system, preserved like cosmic fossils because of the extreme cold and isolation in the outer solar system. Pluto is one of the largest KBOs, but it's not the only significant one. Besides Eris, which I mentioned earlier, there's Makemake, which is about 2/3 the size of Pluto, and Haumea, which is unusual for its elongated shape. There's also an object called Quaoar, which is about half Pluto's size, and Sedna, which has an extremely elliptical orbit that takes it far beyond the Kuiper Belt at its farthest point from the Sun. Some scientists argue that the existence of the Kuiper Belt actually strengthens the case for considering Pluto a planet. They suggest that we should define planets based on their intrinsic properties, like being large enough to be rounded by their own gravity, rather than their orbital context. Under such a definition, Pluto would be a small planet that happens to exist in a belt of similar objects, just as Earth is a terrestrial planet that exists in the inner solar system. Sorry about that. Where was I? Oh, yes, the Kuiper Belt. Another interesting thing about the Kuiper Belt is that it seems to have a relatively sharp outer edge at about 50 AU from the Sun. Beyond that, the number of objects drops off dramatically. This edge is often called the Kuiper Cliff, and its existence is still something of a mystery. One theory is that the gravitational influence of a large, unseen object, sometimes called Planet 9 or Planet X, not to be confused with the original Planet X that led to the discovery of Pluto, might be responsible for this structure. This hypothetical planet would be several times the mass of Earth and orbit hundreds of AU from the Sun. The evidence of Planet 9 is indirect, based on the clustering of orbits of some distant Kuiper Belt objects that seem to be influenced by the gravity of something large. But so far, despite several searches, no such planet has been detected directly. If it exists, it would be too distant and dim to be easily spotted with current technology. So there might still be a true ninth planet out there after all, just not the one we originally thought. Wouldn't that be something? The astronomers who originally searched for Planet X and found Pluto were right that there was another major planet, just wrong about which object it was. Let's talk about why the study of Pluto and the Kuiper Belt matters. Why do astronomers spend so much time and resources studying these distant, cold objects that have no direct impact on our lives here on Earth? Well, for one thing, the Kuiper Belt is essentially a preserved relic of the early solar system. The objects there have been largely unchanged for billions of years, so studying them gives us insights into the conditions and materials that were present when our solar system was forming. Understanding how our solar system formed and evolved is not just academic curiosity. It helps us understand how planets form around other stars, which is a booming area of research. And understanding the distribution of materials in the solar system, where the water, carbon compounds, and other building blocks of life ended up, helps us understand why Earth developed conditions suitable for life. The Kuiper Belt, including Pluto, also represents a sort of bridge between our solar system and interstellar space. It's the frontier, the boundary region where the sun's influence begins to wane. Studying this region helps us understand our place in the galaxy. And finally, I think there's something deeply human about exploring and trying to understand the unknown. Pluto, for decades, was this enigmatic pinpoint of light at the edge of our known world. The New Horizons mission transformed it into a real place with landscapes, weather, and its own fascinating features. There's something profound about that transformation from abstract knowledge to concrete understanding. I guess I should address one more Pluto-related topic that has captivated the popular imagination: the possibility of life. To be clear, Pluto is extremely cold, with surface temperatures averaging around negative 380 degrees Fahrenheit or negative 230 degrees Celsius. That's way too cold for liquid water on the surface, which is generally considered a prerequisite for life as we know it. However, there is evidence that Pluto might have a subsurface ocean of liquid water, kept from freezing by the heat of radioactive decay in its rocky core and insulated by the thick ice above. Similar subsurface oceans are thought to exist on several moons of Jupiter and Saturn, such as Europa and Enceladus, and these are considered some of the most promising places to look for extraterrestrial life in our solar system. That said, any potential ocean on Pluto would be much colder and less energetically active than those on Europa or Enceladus, making it less promising for life. But the fact that we're even discussing the possibility of liquid water on a world so distant and cold shows how much our understanding of the outer solar system has evolved. Excuse me, I'm not bored, I promise. I'm just getting a bit sleepy myself, which I suppose is part of the idea here. Before we start wrapping up, let me circle back to the question of Pluto's planetary status, because there have been some interesting developments since the 2006 decision. In 2017, a group of planetary scientists, including New Horizons principal investigator Alan Stern, proposed a new definition of planet that would restore Pluto's planetary status and add dozens of other objects to the planet category. Their definition focuses on the intrinsic properties of the body itself rather than its orbital context. Essentially, they propose that a planet is any round object in space that is smaller than a star. Under this definition, not only would Pluto be a planet, but so would Eris, Ceres, and even Earth's moon. This definition hasn't been adopted by the International Astronomical Union, so officially Pluto remains a dwarf planet. But it illustrates the ongoing debate in the scientific community about how we should categorize objects in our solar system. And maybe the takeaway here is that these categories, planet, dwarf planet, asteroid, comet, are human constructs that we use to make sense of the cosmos. Nature doesn't care about our labels. Pluto is Pluto, regardless of what category we place it in. It's a fascinating world with its own unique characteristics and history, and that's true whether we call it a planet or not. Let's also talk about Pluto's cultural impact, because it's pretty significant for such a distant, tiny world. Pluto's discovery in 1930 was a big deal. It made front-page news worldwide and turned Clyde Tombaugh into a celebrity. The planet has appeared in countless science fiction stories, movies, and TV shows. Perhaps most famously, the Disney character Pluto the dog, Mickey Mouse's pet, was named after the newly discovered planet. The coincidence of timing is striking. Disney introduced the character in 1930, the same year Pluto was discovered. Pluto has also been the subject of numerous songs, poems, and works of art, and there's something about it. Perhaps its remoteness, its smallness, or its position at the edge of our solar system that captures the imagination. And then there's this strong reaction to its demotion from planet status. People who have no particular interest in astronomy still often have strong opinions about whether Pluto should be considered a planet. It's rare for a scientific classification issue to generate that kind of widespread emotional response. I think part of it might be that Pluto represents the boundary of our knowledge, the edge of what's familiar. There's something poignant about that position. Not quite part of our intimate solar system neighborhood, but not quite part of the vast unknown beyond either. It's a borderland, a liminal space, and those have always fascinated us. Well, I think we've covered quite a lot of ground tonight, from Pluto's discovery as a result of a mistaken premise, to its brief career as a planet, to its reclassification and the subsequent controversy, to the New Horizons mission that transformed our understanding of the distant world. We've explored its unusual orbit, its composition, its moons, and its place in the broader structure of the Kuiper Belt. What I find most fascinating about the Pluto story is how much it illustrates the process of science. Scientific understanding is not static. It evolves as we gather more information and develop new frameworks for understanding. The shifting status of Pluto from planet to dwarf planet is not a failure of science. It's science working as it should, adjusting classifications and theories based on new evidence. And yet, There's also this human element, the emotional attachment we form to ideas and classifications that we've grown up with, the tension between scientific precision and human sentiment is part of what makes the Pluto story so compelling. So the next time you look up at the night sky, remember that out there, over 3 billion miles from where you stand, is a small, icy world with nitrogen glaciers, methane snow, possible cryovolcanoes, and its own system of moons. A world that, for nearly a century, has captured our imagination and sparked our curiosity about the distant reaches of our cosmic neighborhood. Thank you for listening to Dormant Knowledge. If you're still awake and hearing my voice, I appreciate your attention. But if you've drifted off to sleep somewhere along the way, which was partly the goal, then you won't hear me say this anyway. Either way, I hope some knowledge about the fascinating world of Pluto has made its way into your consciousness or perhaps your dreams. Until next time, this is Deb, wishing you restful nights and curious days.